Good evening, everybody. Welcome back to the third and final lecture in the series of Judaism and Science. Is there a conflict? So far, in the last two classes, we've elaborated on the number of different ideas. We brought up some potential conflicts. We spoke about the idea of, was there creation? Did the universe have a beginning? And we mentioned that scientific theory was, for 2,000 years, no. It always was, it always will be, there was no creation. And we explored the Big Bang theory, and we came to the realization that in the 20th century, there's a very different perspective. The scientific community came around to the conclusion, they came back to the first verse of Genesis, that yes, in the beginning there was a creation. We spoke about the idea of creation of time. Time is not a constant, it's not something that objectively exists, but rather it's connected to matter. We spoke about the determination of gender. When exactly is it too late to pray for what kind of child you want? We quoted the Talmud in regards to 40 days after conception. That was also a conflict until the mid-1990s, where science discovered that indeed up until about day 43, the gender can change. We spoke about the age of the universe. How does that fit with the literal translation, the simple understanding of the beginning of Genesis? And we explored that using the lens of some of the ancient Kabbalistic works. We explored the origin of man. We explored evolution. We spoke about the length of an average lunar month. And we spoke about the idea of reoccurring comets. Some of the things we've touched upon. What I'd like to do now is open up a dialogue. There's a principle which is known as the anthropic principle, which basically states, if you look into the universe, if you look into our world, you'll come to the recognition that it's impossible that it's just here by chance, that we're just the product of coincidence. And if you'll explore the life around us, human being, the animal kingdom, and everything that we have access to, you'll come to the realization that everything was fine-tuned for life. That's the anthropic principle. So I'd like to go through some of these ideas with you, because until now, we've discussed potential conflicts, and we've seen that in many cases there is no conflict, or at least potentially there's no contradiction. What I'd like to do now is actually take a step forward and go through some of these ideas that are part of the anthropic principle and see, hopefully, pretty clear indications that there is a purpose, life is not random. So let's first explore our world. Planet Earth, here we are, little speck in the middle of the galaxy of the Milky Way. The galaxy itself, the Milky Way, is estimated to be about 100,000 light years from one end to the other. 1 light year, anybody know how long 1 light year is?
1 year.
6 million.
Close.
The distance that light travels in 1 year.
Right. That is 7 trillion miles. So 7 trillion times 100,000 is the distance of the Milky Way. We're a little speck in this massive galaxy. The Milky Way is estimated to be one of billions of galaxies in the universe. So we're in a pretty big place. If you look at our planet, though, and you analyze what exactly we are, the Earth itself, is the Earth straight? It's going around the sun. We spoke about last time, that's a solar year, the time it takes for the Earth to go around the sun once. When the Earth's going around the sun, we know it's tilted. It's tilted 23.5 degrees. That's based on the gravitational force of the moon, because number one, the size of the moon and the proximity of the moon to the Earth, that pulls it in a certain direction to tilt the axis of the Earth. Therefore, when it's going around the sun, it's not straight, but rather it's tilted. So what? Some people look at that and say, you see, things aren't perfect. It's a little bit out of whack. If you explore it deeper, though, you'll find some interesting things. Based on the fact that the Earth is tilted, that's why we have seasons. Now, I wish I had a diagram, it'd be easier to demonstrate. But if you could imagine for a moment the Earth tilted going around the sun, that means by definition, when the sun's in the middle, where the sun hits the Earth is not always going to be in the exact same spot. Because it's tilted, depending on the time of the year, the sun will be directly hitting the Earth in a slightly different place. If the Earth was just straight, so as it's traversing the sun would still be impacting the Earth in the exact same spot. We wouldn't have seasons. The climate control that we have based on the tilt of 23.5, it would be a totally different planet. Very, very difficult, almost impossible to maintain human or any kind of life. We see as well that as it's going around the sun, it's not just floating, but it's spinning. One rotation of the Earth takes 24 hours, that's referred to as a day. So what? Let's say the Earth didn't spin. Well, we wouldn't be alive. If the Earth didn't spin, that means the side that's always facing the sun would be hundreds of degrees, and the side that's away from the sun would be freezing cold. On either side of the planet, no life could ever develop. Let's say it was spinning, but it wasn't spinning quite as fast. It was spinning slower. Instead of 24 hours to make one rotation, let's say it took a couple of days. Would that be any different? It would be drastically different. Because you would have periods of burning and freezing, and even if theoretically it wasn't that much slower than it is now, maybe life could be possible. Very unlikely though. So number one, the fact that it's tilted. Number two, the fact that the Earth is spinning. Number three is the radius of the Earth. Anybody know how big the Earth is? Big, gigantic ball. So if you were to measure it from one end to the next, you would go from the equator, the middle point. So from one end of the Earth to the other end of the Earth, it's 6,378 kilometers long. Okay. Let's say it was 4% smaller. That means take away 250 kilometers. What would happen then? Besides the temperature, but the gravity would decrease. Much of the atmosphere would thin out. Why do we need the atmosphere the way it is? It holds in oxygen. If the atmosphere would thin out, oxygen would dissipate, we wouldn't be alive. So not only the tilt of the Earth, not only the rotation of the Earth, but the exact size of the Earth is all seemingly set up perfectly for life to exist. We have the size of the sun. Everyone here in Florida for sure and throughout the world try to put on sunscreen, got to be careful of the UV radiation. If the sun was slightly bigger, we couldn't survive. If it was slightly smaller, we couldn't survive. The distance of the Earth to the sun, if we were slightly farther away, we would freeze. If we were slightly closer, we would burn. Everything seems to be pointing in the direction that somehow this little speck of dust wasn't just randomly placed here, but there was some goal of ultimately creating life. What is the most precious commodity we have on planet Earth? Something.
Air or water?
Water. Air. What's so unique about water? Anybody know? I have a cup right over here. Say a bracha on a glass of water. What's that?
In existence, 3 states.
Cool.
Could you turn the air down a bit? Freezing? Yes. Just a little bit.
4 degrees.
Any matter that we have on planet Earth, any liquid, when it gets warmer, it expands. The molecules separate. When it gets colder, what happens? Contracts, condenses, gets tighter. And we see that with ourselves. When you're in warm weather, you naturally feel more relaxed and more laid back. When you're in colder weather, you tense up. I happen to think that might actually be the reason why the mentality here in Florida is so much different than the mentality in, let's say, Brooklyn. There might be other reasons as well, but I think in the colder atmospheres, you know, the environment plays a big role. If I'm constantly cold, that creates intensity, that creates more passion. And here in Florida, it's always warm, always chilled out. Somebody told me a story actually in Seattle. Seattle, they say, is somewhat similar, although it's a little bit colder, but people are also kind of laid back. So somebody moved to Seattle from New York, and he said, I was so amazed that I would be stopped at a red light, and I might be playing on my phone for a second, the light would turn green, nobody would honk. I would look up, people are behind me waiting for me to go, and then I would just go. It was an amazing thing. He said, one time though, I was at a red light, lost focus for a moment, and I hear someone right away, the light turned green, honk, honk, honk.
New York lights.
I was so confused. Are we in Seattle? So he rolls down his window and says, "Nu, tazuz, tazuz." That's Hebrew for move. Different mentality. True story. But anyways, that's the way things usually work. When something gets colder, it gets more condensed, more contracted, and therefore it gets heavier. Something gets warmer, it becomes looser, separated, and therefore lighter. Water pretty much does that within a range of 4 degrees Celsius to 100 degrees Celsius. In Fahrenheit, for those of us who are not from out of America, that's basically around 39 degrees Fahrenheit to 212 degrees, which is the boiling point. Within that range, water is pretty similar to everything else on planet Earth. Once you go below 4 degrees Celsius or 39 degrees Fahrenheit, then something very, very strange happens to water. As it gets colder and it gets closer to freezing, it actually starts to expand. Up until that point, it's getting more condensed, heavier, more tightly packed, so to speak, the molecules. Once it gets closer to the freezing point, then it starts to loosen up. Once water turns into ice, the molecules are very separated, very laid back, so to speak. That means that therefore it's a lot lighter. Therefore what? It floats. The seas, the lakes, in many places in the world where the temperature drops below 32 degrees. So what happens is the top of the sea or the top of the lake will freeze. Many oceans in colder parts of the world. Now, if water didn't work in this strange way, what would happen instead? The top layer, as it's becoming colder and colder, and it's condensing and it's contracting, that would freeze, and that would be even heavier than the water itself. That would sink to the bottom. And then it would freeze again and sink to the bottom. Freeze again, sink to the bottom. What would happen to all the plant life, all the animal life, all the sea creatures in the ocean and the lakes?
Die.
They would die. They couldn't survive. Most of the oxygen that we get to live, that we need to live, is not from the forests. It's from the sea. All the algae and the different vegetation miles under the ocean is our main source of oxygen in order to live. So if water worked slightly different, if it worked in the normal way, also it would be pretty much impossible to survive. This is referred to as the anomaly of water. So we have the axis of the earth, we have the radius, we have this distance from the sun, and we have the anomaly of water. You think about the idea of drinking water. Where does water come from? When you turn on the cold water, where does it come from? So around here you probably think it comes from the canal, right?
That comes from the treatment plants.
Okay, so where does that water come from?
Underground.
Where does that water come from?
See?
No, it doesn't come from the sea. From the ground.
Yeah,
Lake
the cycle.
It's
Right?
what?
It evaporates and then it falls back down. It
Right.
evaporates from the ocean, then it falls back down as rain.
The majority of drinking water that we have is from the ocean. I ever tried to drink ocean water? I was just there with my children last week, and my 3-year-old daughter got some of the ocean water in her mouth, and she was crying, "Tati, it's so salty, it's so salty." But what happens is, there's an interesting system, that because of the distance of the sun from the earth, it's hot enough to evaporate the water. Water is the perfect combination of molecules that it's able to evaporate not too much where it just dissipates, and not too little where it doesn't do much, but it actually, the evaporation process is a filtering process. As the water evaporates into the sky, all of the salt and the dirt and all the junk in the ocean stays in the ocean. The essence of that water, the vapor, rises up. Those form into clouds. Then there's something called wind, right? Meaning, granted, we might have clouds above the ocean, but we don't live in the ocean. We live in the dry land miles and miles away. So how does that water get to us? That's through wind. Wind carries these clouds across the earth. Then you have a process of rain, condensation of the water, and now you have filtered water coming down from the heavens, and that's the source of all the life that we have. Human life, animal life, plant life. When you look at that from an objective perspective, and you ask the question, did that just happen to work like that? Happen to be in this perfect balance of the temperature enough to cause evaporation that creates the clouds and the wind just in the right way, and the rain? It seems like, at least superficially, that this was somehow set up. This is somehow here to ensure that there's life on planet Earth. So someone might say as follows, okay, Rabbi, that's cute. Nice ideas. But listen, we know there's billions and billions, there's actually trillions of stars in the universe. And in all these trillions of stars, theoretically, there might be trillions of different planets out there. So maybe we get lucky. All of these things with the tilt and how far it is from the sun and the water and the oxygen and the radius. Okay, what do you expect? 1 in a trillion, so you're the one. So I think the response to that is let's take a step back. It's true that logic might say that we got lucky. But if you could somehow show me intrinsic design or intrinsic intention in the very makeup of the universe, then there's no argument. Because the universe itself is everything. Does it make sense for the universe to be here? Does it make sense for the Big Bang to have created what it did? So we have over here, I don't want to take you back to high school chemistry, right? But this is the classic picture of the atom. We have the nucleus in the middle, and inside we have the protons and the neutrons, we have the electrons going around the nucleus. Subatomic particles, we've discovered recently, are even smaller, more fundamental than the atom itself. Now, if these are the building blocks for all of reality, everything that we have, everything that we see, everything that's part of who we are based on these building blocks, what makes these building blocks work? So, there's a nuclear force here that makes the atom what it is. If this nuclear force was 2% weaker, meaning that it didn't have that same strength pulling in the energy around it, no atoms with multiple protons could exist. Who cares? Why do we need atoms with multiple protons? Professor? How many atoms are there with multiple protons?
About 100.
How many atoms are there without multiple protons?
Just one.
What is that?
Hydrogen.
100%. All we would have is hydrogen. Can we live on just hydrogen? Can't do much with just hydrogen, right? That's if it's 2% weaker, there would be no life, there would only be hydrogen, and you can't do much with just hydrogen. Let's say it was 1% stronger. That nuclear force was 1% stronger, then hydrogen would be extremely rare. So that's an amazing thing. The building blocks of life as we know it, the only reason why anything is here, existence is possible, is based on atoms, is based on subatomic particles. And the only reason why these things work to create life is because they seem to be very fine-tuned. 2% weaker, all you would have is hydrogen. 1% stronger, you wouldn't have any hydrogen. In either case, it wouldn't work. It seems to be perfect in the middle to allow life to exist. Electromagnetic force, the idea of a molecule. What's a molecule? Basically a couple different atoms coming together that forms a molecule. Now for the atoms to be able to combine and be friendly and connect, so there has to be just that perfect amount of force where the atom is keeping the electrons close by, but not too close by. If the electrons are too close or too condensed into the nucleus, it couldn't combine with other atoms to form molecules. If it was too weak, if that electromagnetic force was too weak to hold the electrons together, so then you also couldn't form molecules because it would be too loose, so to speak. So even to form the basic building blocks of life, to have the molecules, this electromagnetic force has to be pretty fine-tuned as well. Dr. Paul Davis made a calculation that if the force of gravity was either stronger or weaker by 1 part in 1,040, nothing would exist. The force of gravity would be stronger or weaker in 1 part in 1,040. Life as we know it could not exist. If you look at the universe and all the different elements, what is the universe composed of? So the modern scientific theory is that there's 4% of regular matter, there's 23% of dark matter, 73% of dark energy. If there was slightly more dark matter, if there wasn't 23%, but let's say there was 27%, at that initial major explosion of the Big Bang, everything would have collapsed immediately. If there was any more dark matter, there would have been too much force, too much gravity pulling everything back together, the universe never would have expanded. There's 73% of dark energy. If there was slightly more than 73%, the universe would expand way too fast, never having time for stars to form, for planets to form, for life to form. So it seems like not just our planet is very fine-tuned, which one could argue we're the lucky ones, but the universe itself is actually very fine-tuned. I want to read you here, but have the pamphlets. It's on page 14, the first page of the pamphlet, the bottom of the left-hand column. Dr. David Deitch of the Institute of Mathematics of Oxford University, he wrote as follows: if we nudge one of these constants just a few percent in one direction, he's referring to the physical constants here that make up the universe. Stars burn out within 1 million years of their formation, and there is no time for evolution. If we nudge it a few percent in the other direction, then no elements heavier than helium form. No carbon, no life. Not even chemistry. No complexity at all. Dr. Paul Davis, who we just quoted, professor of theoretical physics, Newcastle University, he writes, the really amazing thing is not that life on Earth is balanced on a knife edge, but that the entire universe is balanced on a knife edge, and would be totally chaos if any of the natural constants were off even slightly. For example, the fine structure constant, usually denoted alpha, determines the delicate structure of the electromagnetic force that binds the atoms and molecules together. If its value were slightly different, life could not have developed. You see, Davis continues, even if you dismiss man as a chance happening, the fact remains that the universe seems unreasonably suited to the existence of life, almost contrived. You might say a put-up job. Something seems fishy, he's saying. It seems like there's some kind of design, there's some reason that the universe is structured the way it is, and the answer seems to be because we want life to happen. On page 15 here is a quote from Professor Fred Hoyle. It's the bottom of the first column on page 15. He says the very last line, a common sense interpretation of the facts suggests that a superintendent has monkeyed with the physics, as well as chemistry and biology, and that there are no blind forces, so to speak, speaking in nature. I do not believe that any physicist who examined the evidence could not fail to draw the inference that the laws of nuclear physics have been deliberately designed with regard to the consequences they produce within stars. Hoyle is saying the same idea. He feels that any physicist who truly examines the evidence, looks at it honestly, there's no way to come to the conclusion that, I guess, things just happen. Lastly, Stephen Hawking, we're familiar with perhaps his famous book, A Brief History of Time. he writes, this is in the bottom of 15, the remarkable fact is that the values of these numbers, i.e., the constants of physics, seem to have been very finely adjusted to make possible the development of life. Actually, one more thing we have in the next paragraph on page 16 on the right-hand side from Professor Stephen Weinberg. He writes this in an article in Scientific America. He says, how surprising is it that the laws of nature and the initial conditions of the universe should allow for the existence of beings who could observe it. Life as we know it would be impossible if any one of several physical qualities had slightly different values. He continues, page 17 in the left column, in the middle of the second paragraph. One constant does seem to require an incredible fine-tuning, which is, he explains, the existence of life of any kind seems to require a cancellation between different contributions to the vacuum energy accurate to about 120 decimal points. And you have here, he points out how many zeros that looks like. It's a lot of zeros. The common theme is that it seems in the scientific world as well, when we look at the universe and we understand the physics, we understand the chemistry, it seems to be speaking to us. It seems to be telling us there's something, there's a reason, this is fine-tuned for human life. What makes any question important? If you had to define an important question.
Well, it has to be able to be somewhat answerable.
It has to be answerable, okay.
You're asking about the question whether what you try to develop is that basically everything is adjusted in a certain fashion, which the correlation is that it stays the same. You say that the Earth is very lucky. Well, we are not so lucky, because all those laws in our very existence is going to end when our sun is going to die.
Oh.
And therefore, in the Bible, it speaks, and you speak about the creation of the world, but the fact is the destruction of the world, which is related to our sun. So all those rules which temporarily cannot change will change in the moment when the sun will die.
It reminds me of a story. There was a young boy sitting in science class, and he heard his teacher say that she was talking about the sun and its formation, and she said, in 7 billion years, the sun will burn out and we'll all die. So he raised his hand, he said, excuse me, teacher, did you say 7 million years or 7 billion years? And she said, 7 billion years. He said, whew, okay. That is true. You know, the way it looks, that's what stars do. They form, it's a star, in this case it's the sun, and ultimately, after billions of years, it dies out. But I'm not sure that takes away from the incredible preciseness of that, the fact that we have all of these things functioning together to create the potential for living beings who are able to look at the universe and say, wow.
Well, why would human beings disappear if they were created? And there's not no, in the Bible it says that that's a destruction of the world going to happen.
Well, actually, we do have similar, we actually spoke about a couple times ago, the Talmud tells us about the lifespan of existence. So we also have the perspective that there's a beginning and there will be an end. When exactly the end will be, 7 million years, 7 billion years, but I don't think that's necessarily a contradiction.
Can I ask you a question?
Sure.
With all these small percentages differences, imagine if the data was different and you could be 50% off in terms of the angulation of the Earth, you could be 75% off with regards to all these things. Mm-hmm. Let's say that that's what the scientist told you.
Okay.
Would you change your opinion about the existence of God?
You asking a personal question or a theoretical
No,
question?
I mean, you're presenting us with a lot of really cool, interesting physics data. And it's amazing. I mean, the world is an amazing, the universe is an amazing place. But then you take one additional leap, which is this must mean that there's a grand designer, right? So I just wonder, if the data was different, would your conclusion be different?
So we said at the first part of the series that there's 3 levels of conviction as to why anybody feels strongly about anything. Right? There's knowledge, there's belief, and there's faith. Knowledge means I know. I know this is a table. I'm looking at it right now. It's actually not a table, it's a pool table, but it's some form of table. I'm looking at it. That's knowledge. Belief is, I don't know for sure. The example I gave is that my good friend runs in and says, Rabbi Light, your car's being towed. Do I know that to be true? I don't know that because I'm not seeing that. But I know my friend, I know he's an honest fellow, so I assume that to be true. I believe him. That's called belief. I have a conviction, I feel somewhat strong about something, not because I know, but because there's enough logic there to go with. The third form of conviction is faith. Faith means there's no real logic, there's no real reason, there's no anything that's compelling me more than my father told me to believe this, or my environment happens to, have a certain perception, I just follow along. That's called faith. So we mentioned in our first class that Judaism doesn't like faith. We don't do that. The goal is to live life with as much knowledge as possible. Now, a lot of times in life, you're not going to have knowledge. You have to go based on belief. Do I know that she's the girl to marry? I don't know that. You might wake up in 30 years from now and realize it wasn't. But you got to go with your gut. Not just your gut, with your logic as well. If it makes sense, I see potential, we've dated a while, that's called doing something based on belief. You go on the highway to work. Do you know you're not going to crash and die, God forbid? You don't know that. But you believe it to be true as long as you pay attention and hopefully, most people don't get in terrible accidents. It should be okay. So just like we make any other decision in life, in regards to who we marry, in regards to what college we go to, in regards to what yacht to buy, hopefully we should have those decisions also. We should view purpose in the exact same way. When it comes to my belief system, when it comes to my perspective on God, God, no God, yes purpose, no purpose, it should be done in the exact same way as everything else. If science seems to be pointing me in a certain direction, if logic seems to be compelling, so then just like anything else in life, you should go with it, unless you find something more compelling. If you found something more logical, more reasonable than these ideas, let's say you found out some very strong evidence that Buddhism was the real deal. So you know what you should do? Take off your yarmulke, and you put on, I don't know what they wear, but you join them. It's based on logic, it's based on as much evidence as we can find. Now when we ask any question in life, the most important question has to be, how relevant is the answer? Depending on how relevant the potential answer is, that's how important the question is. Right? So we'll always go back to science class. I don't mean to offend you, professor. We have a professor of chemistry here. But you're sitting in science, or let's say math class, and the common question that all the kids are asking, why do we have to learn about logarithms? I don't plan on working for NASA. I don't care what a logarithm is. Good question. Why do we have to do that? The reason why the kids are bothered by that is because they don't see any relevance. How is this going to help me in life? How is this going to affect me in any way, shape, or form? The more relevant the question is, the more important it is. What's the most relevant question? What's the most important question, therefore, that any human being could ask him or herself? Very simple. What in the world am I doing here? It's that basic. Not what am I going to have for breakfast, not what car to buy, not what kind of coffee should I get, not who won the basketball game last night. The most crucial, the most important, the most relevant question that any human being could ever ask is, what am I doing here? I'm on this little speck of dust in the middle of this galaxy, in the middle of this vast and expanding universe. I'm here for a second and I'm gone. Is there any purpose? Is there any mission? Is there any goal?
It's another series.
We're going to touch upon it now. We have a couple more minutes left.
Well, just a quick
Yes.
second.
Sure.
I mean, if universe, size-wise, is infinite, and time is also infinite, aren't humans just a byproduct given where the size and time of everything in the universe is at right now? And to his point, whether it's the sun burning out or the earth heating up a few degrees, a new life form is going to show up somewhere, somehow, that's based on the current conditions at that particular moment of time in that particular space in the universe.
Good question. I would say two things. Number one is the premise I would disagree with. The universe is not infinite. Time is not infinite. The whole theory of the Big Bang is that there was a starting point. Before this Big Bang, there was nothing. We can't fathom what nothing means. When you think of nothing, you really think of space. But nothing means nothing, right? So before the Big Bang, there was nothing.
Of faith, then, isn't it?
Well, I'm saying that's the present modern day, scientific theory, based on, like we spoke about in the first session, based on the calculation that the universe is expanding. Then they come to the conclusion there was a starting point. Before that starting point, there was no universe. The way that the scientists refer to it is that fiery ball, or the way that the Ramban referred to it was something the size of the mustard seed. There was some little speck that somehow contained all mass and energy. When that thing exploded, that was the beginning of the universe as we know it. And what's happened since then, is it 15 billion years since then? Is it 13.7 billion years since then? Is it 6,000 years since then? Whatever it is, it's been expanding. But that means it's not infinite. It started from a point, and it's getting bigger, and it's expanding. But there is a size. And just like the universe itself, the space is finite, time is also finite. Space and time are only trapped inside of this universe. It's a massive universe, but it's not infinite. So therefore, you can't say mathematically, well listen, there's an infinite number of things that could have happened, so I'm sure all of these things could have come together. That's not true.
Oh.
Ooh, what does that mean?
You need another belt.
Please tell the truth.
That is seriously.
Fine tuning.
Fine tuning. But so that's one thing I wanted to respond. The second thing was your idea of developing into a different life form. That might be a true idea. We spoke about last week the idea of the Shemitah, the 7 cycles, each one containing 7,000 years, and perhaps the dinosaurs and whatever was in that period millions of years ago was in a prior set of 7, and we said that we're right now either in the 7th cycle or in the 4th cycle. So according to those who say that we're in the 4th cycle, that means something else will happen. There will be another life form.
I mean, some people say, because we're carbon-based, there's this concept, some scientists think that a non-carbon-based form, the scientific data that you're referring to is relevant to our life form, but there might be other forms that different, data might be more relevant to. So.
True, but that requires leap of faith.
Right.
If
We
you
have
could
no
show
evidence
me, if
of
you have
that.
any evidence whatsoever that could be a different life form, then 100%. But as of now, that itself requires faith.
Right.
So that's the most important question any human being could ask him or herself is, what am I doing here? Most of us don't ask that question. Sometimes we do. Perhaps when we were younger, we did more. We were in college and we were idealistic and we thought we would master the world and become great people and influential people. And as we get older and we come to embrace mediocrity and we realize, I'm not going to save the world, I'm not going to be a great musician, I'm not going to play for the NBA. When I was young, I had aspirations of slam dunking. And I knew I could someday. I'd watch Michael Jordan and he'd do it from the free throw line, and at the time I was 10 years old, but I knew once I would be 6 feet, I could for sure do that. And as I got older and I got taller and I came to the realization I'm still not slam dunking, it slowly dawned on me it's probably not going to happen. And now I know for sure it's not going to happen. So, the same thing is true when it comes to having that energy and that vibrance to embrace life and ask the real questions. We somehow don't necessarily do that. And I think the reason for that is because many of us feel overwhelmed with the question. It's so big. It's such a massive question to ask. It's too much. It's overwhelming. And I think therefore, many secular people continue doing what they're doing without questioning, and many religious people continue doing what they're doing without questioning. Because to ask real questions, to really explore and to probe, is a very hard thing to do for two reasons. Number one, I don't think I'll get anywhere. It's too confusing. It's too beyond me. Number two, I might be afraid to find out the answer. Those are two reasons why I think human beings don't explore this too much. But I'll tell you the truth, I think the whole thing is a misconception. I think the confusion and feeling overwhelmed is a lack of clarity. It's very simple. There's one of two choices. There's one of two reasons why we are here, why we are alive and conscious and being able to relate and communicate to each other. That's it. Number one is, life is random, life is coincidence, there's no objective meaning to what people do as a whole, there's no objective meaning to what I do or choose as an individual. It's all just random, somehow it burst into creation, eventually it's all going to burn out and be destroyed. We're here, we're gone, doesn't make a difference. That's A. B is the universe was created. There was an intention for creation. There was a purpose of creation. We as human beings are not just a coincidence. We're here for a mission. We're here to accomplish something. Those are the only two choices we have, A and B. So it's not that confusing. I want to read to you. This is a book by Rabbi Jonathan Sachs, one of yours. This is the book, The Great Partnership. He has here two stories where he speaks about, and he's always very eloquent, almost poetic. He gives two options. I want to read to you his first option, which is our option A. In the beginning, some 13.7 billion years ago, there was an unimaginably vast explosion of energy out of which the universe emerged for no reason whatsoever. In the course of time, stars coalesced, then planets. Then 4.5 billion years ago, one particular planet capable of supporting life. 700 million years later, inanimate matter became animate. Cells began to reproduce. Life forms began to appear, first simple, then of ever-increasing complexity. Some of these survived, others disappeared. Eventually, a life form came into being capable of complex patterns of speech, among them the future tense and the ability to ask questions. For the first time, something in the universe became capable of knowing that the universe existed, that it might not have, and of asking, what is here? Why are we here? The formation of the universe involved massive improbabilities. Had a single one of the mathematical constants that determine the shape of the universe been slightly different, as we mentioned, even by the order of 1 in a million, there would have been no stars, no planets, no life. Had the evolution of life been slightly different, interesting example he brings, had the dinosaurs not become extinct, for example, there would have been no Homo sapiens, no self-conscious beings, and no civilization. But all of this was an accident, blind, mere chance. It happened. No one intended it to happen. There was no one to intend it to happen. And there is no meaning to the fact that it happened. The universe was, one day it will cease to be. To the question, why are we here, the answer is silence. We, members of the species, Homo sapiens, are wrong to believe that our questions and answers, hopes and dreams have any significance whatsoever. They are fictions dressed up to look like facts. We have no souls. Even ourselves are fictions. All we have are sensations, and even these are mere byproducts of evolution. Thought, imagination, philosophy, art. These are dramas in the theater of the mind designed to divert and distract us while truth lies elsewhere. For thoughts are no more than electrical impulses in the brain. The brain is merely a complicated piece of meat, an organism. The human person is a self-created fiction. The human body is a collection of cells designed by genes themselves incapable of thought, whose only purpose is blindly to replicate themselves over time. Humans might write novels, compose sympathies, help those in need, pray, but all of this is a delicately woven tapestry of illusions. People might imagine themselves as if on stage under the watchful eye of infinity. But there is no one watching. There is no one to watch. There is no self-conscious life elsewhere, either within the universe or beyond. There is nothing beyond sheer random happenstance. Humans are no more significant and less successful at adapting to their environment than the ants. They came, they will go, it will be as if they had never been. Why are we here? We just are. Very eloquent. That's A. B is, we're here for a reason. B is that we know intuitively, through our life experience, putting aside the logic for now, putting aside our science, putting aside the last 2 classes, we feel certain things to be significant. We feel certain things to be real. We feel certain aspirations and missions and dreams that we have to be substantial. We know almost intuitively that, objectively speaking, the choice that I do make makes a difference. That's option B. Those are the only 2 options. So it's not that complicated. Somebody will say, okay, I grant that. There's A and B. And let's even say I embrace B. I feel, based on the logic, based on the scientific evidence out there, based on my own intuitive experience and feelings, that there has to be some kind of purpose. But how am I supposed to find that purpose? We live in a world where there's millions and millions of philosophies and cults and religions, and how in the world am I supposed to find that truth? It's beyond me. There's no point, therefore, pursuing it. Tell me why, logically speaking, that claim is illogical. No pressure.
It's not illogical, you just do what mom and dad do. It's very easy.
But if a person's searching for truth...
99% of the planet does that.
But I'm talking about the 1%. I'm talking about the 1% who's not satisfied with that. The 1% who's a real searcher. So how do I find it? If I'm embracing B, I feel that there is a purpose out there. I know there's a purpose, but how do I know what it is? I was born into this particular religion, or this particular culture, but that doesn't mean, therefore, this is right. How do I find the right one? Many people will say, you can't. Right? It's beyond me. The reason why that's illogical, and this is not philosophy, this is just very simple logic. If there is a mission, if there is a purpose as to why we're here, if it would be impossible for me to figure out what that purpose is, that purpose would be purposeless. If I'm supposed to be doing something here, if I'm supposed to be accomplishing something, but yet I can't figure out what it is, it's too complicated, I don't like philosophy, I can't get to it, that means there is no purpose. So if a person feels deep down, I am here for a reason, that means by definition, you're able to find out what that reason is. So at least, I'm not telling you what that reason is, but I'm telling you that logically speaking, it has to be accessible. So how do you go about accessing, how do you go about attaining that truth?
Search for it.
Well, that's number 1. Number 1 is you got to be a searcher. If you just go based on what mom and dad did, you might not find it. So you're searching, you're asking questions. Asking questions in Judaism is something that's viewed as sacred. It's the holy of holies. To be able to ask, to be able to question everything, not to take anything for granted. So I'm questioning and I'm searching. Where do I turn? I think that if you look around the world, to say, let me study every religion, every philosophy, and then I'll make a decision. Good luck. Unless you live hundreds of thousands of years, you're not going to master everything, trust me. So what do? You just ask one question. We were having this conversation. You ask people one question. You claim to have the truth? Mr. Priest, Mr. Minister, Mr. Rabbi, Mr. Imam. That's beautiful. I love you. Tell me, logically speaking, why? Don't tell me how beautiful it is what you believe in. Don't tell me all the psychological benefits of believing what you believe in. I don't care about any of that garbage. Tell me logic. Put your money on the table. Can you show me, intellectually speaking, why this makes sense? If the answer is no, if the answer is just have faith, then my response would be, okay, thank you very much, have a nice day. Let me look elsewhere. In my search and my experience, and I want to end off this series with a dare, which is look elsewhere, explore, try to find any other source of meaning or purpose that's here in planet Earth, where they can tell you, I have evidence, I have logic, I have reason to believe what I believe, and it's not just based on faith. Where I'm not trying to convince you, just believe. I'm not trying to convince you just to do something because I'm so cool and you should follow my ways. But I'm doing something because it makes sense. If you have the oldest religion on planet Earth, the only source of human beings that were here from antiquity, who somehow claim to have received this tradition going back from divine sources, a tradition telling us what the mission is here in this world as a human being. And somehow this is the only religion that made it through those ancient and primitive times, and it's still alive and vibrant today. And it's the religion that all the religions of the world, the major monotheist religions, based themselves on. Christianity, later on Islam. The idea of monotheism, the idea of morality as we know it, the idea of equality, the idea of justice, all of the morals and aspirations that we live by, where do those things come from? Who was the only nation, the only religion to ever claim that there was a national revelation? That it wasn't one man who heard the word of God, but it was millions of people who actually experienced this real, direct, intimate connection with the creator of the universe. Where do you find such a radical, absurd claim?
Mount Sinai.
Mount Sinai. That's the only place you find it. It's a claim that's so radical that it was never repeated throughout history because you can't make those things up. I happen to think that if you look through it and we focus and we don't ignore the question, but we embrace the question and we keep on exploring and we keep on searching and we don't feel, I'm never going to get there. If there's a mission, it has to be accessible. I think throughout this series we've got a little bit involved with some of these, scientific points. We have to be in tune with some of these psychological points as well. But my mission to you is keep on searching, keep on asking questions, and I think you'll find the truth. Any questions?
My head's exploding.
Have a wonderful evening, everybody. The next series, by the way,
Yes.
will be entitled The Truth About Kabbalah.
Wow.
And that's going to be 3 Tuesday nights again, starting, God willing, I think it's the 19th, February 19th. So we'll take a couple weeks off.
Right.
Our head's been exploding too much. Take some time to relax. Have a wonderful evening, everybody.
Good to see you. How are you?
Let's do a camera. Can you get up the camera? Just the red button, I think.
On the back?
Uh-huh.